Welcome to this explainer. Today, we're uncovering the hidden, invisible mechanics running the physical world all around us.
Could you ever measure 4 kilos of love? No way, right? Let's rethink what makes something physically real.
Here's the deal. To be considered matter, stuff needs mass, and it has to take up physical space. So water, almonds, and even the air we breathe, that's matter. Love and hate? Definitely not.
It's wild to think about, but just one single drop of water holds millions of invisible particles. And these tiny building blocks always play by 3 strict rules. They have space, they move, and they attract.
Take Rule 1, space. If water is just tightly packed particles, how do fish survive underwater?
Well, they're breathing oxygen trapped right inside the tiny, empty gaps between those water molecules.
Rule 2, particles move. The smell of hot food hits you fast, while cold food doesn't. Why?
Heat gives particles kinetic energy. They vibrate, bounce around, and spread super fast through the air.
Rule 3 is attraction. Snapping chalk is easy, but an iron nail's particles grip together fiercely.
These exact rules actually dictate how matter forms into 3 distinct states: solids, liquids, and gases.
Now, solids shouldn't be compressible. So how on earth can you easily squish a solid sponge?
It's a total illusion. You're literally just squeezing trapped air out of tiny holes hidden inside.
So how do we force these particles to shapeshift from a solid into a liquid or gas?
We just change the temperature. It forces particles apart or pulls them tightly back together.
In chemistry, we measure this heat in Kelvin. You literally just add 273 to your Celsius temperature.
For example, ice melts at 0 degrees Celsius and water boils at exactly 100 degrees.
Adding heat causes melting and vaporization simply by overpowering that strong attraction force between the particles.
Cooling reverses the whole journey. It pulls particles back together through condensation and solidification. Sometimes, a solid completely skips the liquid phase and jumps straight to gas. That's called sublimation.
Here's a crazy mystery. While melting, the temperature stops rising. Where does that extra heat actually go?
It turns into latent or hidden heat. It's totally busy breaking those invisible bonds between the particles.
This hidden energy basically unlocks the physical transformation without ever changing the thermometer's reading.
Next time you drink water, will you picture those millions of dancing particles? Keep questioning the invisible.